Good evening, everybody. Welcome to another episode of Cosmos from Your Couch, brought to you by the Dunlap Institute at the University of Toronto. My name is Michael Reed. I'm the Public Outreach Coordinator for the Dunlap Institute, and I'm going to be your host for this talk. I'm very pleased to introduce my colleague, Dr. John Percy, who's going to be talking to us tonight about Toronto's astronomical heritage. And the presentation will go for around an hour. We will be taking questions, but we'll be taking those at the end. So please feel free to share your questions at any time in the chat window on YouTube, and we'll compile those and share them with Dr. Percy at the end, and he'll be happy to answer your questions. So just by way of introduction, Dr. Percy is a very active professor emeritus at the University of Toronto in astronomy and astrophysics, and also in science education. He was a founding faculty member at the University of Toronto's Mississauga campus in 1967. His research deals with the nature and evolution of the stars, and he's published over 250 research papers, which is a lot, and 3 books in this field, including Understanding Variable Stars, which was published in 2007. He's been active in science education, particularly astronomy education at all levels throughout the world. He's edited 5 major conference proceedings in the field of astronomy education, has been president of 6 national or international scientific and education organizations, has been the vice chair of the Board of Trustees of the Ontario Science Centre. He served as the honorary president of the Science Teachers Association of Ontario, and has received many, many awards for his work, including the inaugural University of Toronto President's Teaching Award in 2007, as well as the Keelak Award offered by the Canadian Astronomical Society for outstanding contributions to the public appreciation of astronomy in 2012. He also received the Education Prize of the American Astronomical Society in 2013, and is a fellow of both the American Association for the Advancement of Science and the Royal Astronomical Society of Canada. So hopefully you take from that introduction that Dr. Percy is a very esteemed astronomer with wide-ranging expertise in both astronomy and public outreach, and we are very, very pleased to have him here tonight to talk to us about Toronto's astronomical heritage. Welcome, Dr. Percy.
Okay, you give me the word as to when we can start?
You can start.
Okay, so are we live?
Yeah.
Okay, well, thank you very much, Mike, and good evening, everybody, on this very hot, humid, typical Toronto summer evening. Now, Torontonians tend to think that their city is the center of the universe. That's a joke all across Canada. So what I'm going to try and convince you tonight is that at least astronomy-wise, we're at least a center of the universe. And I'm going to try and convince you that in connection with the way that our city has grown and our country has grown. So we're part of the history and heritage of Toronto and Canada. And that's what I'm going to try and do today. Now, first caveat is that I'm an astronomer. I'm not a historian. I'm not even a good amateur historian, but I'm very interested in it. And maybe my greatest qualification is that I've lived through quite a bit of what I'm going to be outlining for you tonight. But this presentation really started back in International Year of Astronomy 2009, which was a worldwide celebration of the 400th anniversary of Galileo's development and first use of the astronomical telescope. One of the things that we wanted to do is to connect with new audiences. And because I was a great fan and supporter of Heritage Toronto, and I'd been on some of their walking tours, I decided to develop a walking tour about Toronto's astronomical heritage. And then I turned it into a presentation, so I'd have something to do during the winter and times when we couldn't do the Heritage Walk. So this was a wonderful occasion, over 3,600 events in Canada, reaching almost 2 million people. And a lot of that because of partnership with amateur and professional astronomers and educators all across the country. So one thing we should start with is that astronomy has been done in Canada and in the Toronto area for thousands of years. And any of you that caught the Cosmos from Your Couch program 3 weeks ago and it is archived. There was a wonderful presentation on the astronomy of the Mi'kmaq civilization, which is very much representative of the way that our Aboriginal people have used the sky as a clock, a calendar, and a compass. And it's still a very important part of their culture and their spirituality. But we're going to pick up the sort of conventional history of astronomy, which of course is the Copernican revolution and the work of Galileo and Isaac Newton and so forth, building of course on the work of many other astronomers from many other civilizations that came before. One thing I should point out is that during these dates that I've ascribed to the Copernican revolution, we already had the beginnings of a university in Canada at Laval in Quebec City. Harvard had already been established. It's just that Toronto was a couple of centuries behind as far as academic things like this were concerned. So in the 18th century, science continued to flourish. A couple of major things were the connections developing between science and the humanities and the arts, and science becoming available to a more general audience through lectures like this one, demonstrations, museums, and so forth. And if you want to find out more, there's this wonderful book called The Age of Wonder by Richard Holmes, which discusses that, not just the astronomy, but all the other sciences that were developing and flourishing in the 18th century. And again, to put things in perspective, by the 18th century, there were small universities springing up in Atlantic Canada, but again, Toronto was still behind the curve as far as such things were concerned. But we took off very rapidly at the beginning of the 19th century, and whereas Toronto was just a town of York of a few hundred people at the time of the War of 1812, by 1850 it was a major city of Toronto. It had been the capital of Upper Canada and became, at least temporarily, the capital of Canada West. It had a university, at least on paper, in 1827, and things really were starting to happen. So we pick up the story at that point in 1840, and the British Admiralty had developed an international project to try and figure out why the compass needles on ships, for instance, wandered on timescales of hours to years. Of course, that was a major problem for an empire like the British Empire. And so they set up little observatories around the world, including one on what's now the campus of the University of Toronto. And they figured out that the problem was the interaction of the sun and the earth, what we now call space weather, energetic particles from the sun that were striking the earth's magnetic field, and so forth. So anyway, they published their results and they packed up their equipment and took them back to the mother country. And that would have been the end of the story, except that Toronto was starting to feel its oats. It was or had been a capital city. It was a major center now. And so it was decided by the government that what we really needed was an astronomical observatory. And so this one here was built and opened in 1853, the Toronto Magnetic and Meteorological Observatory. So as the name suggests, it was concerned with the more practical aspects of astronomy, magnetism, meteorology, timekeeping, surveying, and things like that. So it was very much practical astronomy in those days. And another aspect of practical astronomy was its use in surveying, which of course was very important both to Toronto and Canada in those days. And so if you happen to ever go on a Heritage Toronto walking tour, in particular mine, this is what it looks like on the left-hand picture there. And we're looking at this concrete pillar, which is on the right-hand side of the picture here. And there's a brass plaque there on which is recorded the precise latitude, longitude, and elevation of this site for purposes of surveying. And all other surveying could be done relative to that point there. But astronomy was becoming more than just a practical thing, and that was true of science in general, and popular interest was starting to develop. Now, in the previous century, things called mechanics institutes had popped up in England and Scotland as a result of the Industrial Revolution as a way of providing education for people like mechanics and so forth. And Toronto got its first Mechanics Institute in 1830 when it was still the town of York. And this eventually, as this heritage plaque says, eventually developed into the Toronto Public Library in 1884, which is now the busiest public library in the world. So here we are, the center of the universe as far as public libraries are concerned. And there was also interest on the part of more professional people, notably Sandford Fleming, later Sir Sandford Fleming, engineer, surveyor, map maker, railroad builder, entrepreneur. He was there at the driving of the last spike on the Trans-Canada Railway. Is known particularly for being a successful proponent of standard time, which was a great asset to the railways, where now you didn't have to have different time at every single station along the line. So he's particularly known for that, but he was also a co-founder of an important organization called the Canadian Institute, rather quickly the Royal Canadian Institute, now the Royal Canadian Institute for Science, which had a very major role to play in Canadian science, particularly in the late 19th century, where it served as our sort of Academy of Science, publishing Canadian scientific work and so forth. So it was a place where professional and educated people could come together to talk about the latest developments in science and technology. Well, there's always a few people that want to talk about astronomy. So in 1868, a group of what are traditionally called laymen, and they were all men at that time, gathered together to form the Toronto Astronomical Club. Now, the club had some ups and downs and changes of name, but by 1890, it was the basis for the Royal Astronomical Society of Canada, which is a very important organization both then and now. It's primarily an organization of amateur astronomers now. Prior to the year, let's see, 1971, it was the only major astronomical organization of Canada, but it does very important work. And I'll point out particularly that in 2003, it was the recipient of a very prestigious award from the Canadian government for excellence in science outreach. So it's just celebrated its 150th birthday, a year after Canada did, and continues to do wonderful work. For those of you who are not familiar with amateur astronomy, it's a very diverse field. There are amateur astronomers who simply sit and listen to presentations like this one, or they become familiar with the sky, or they develop very sophisticated instruments and make superb photographs of the sky. And some actually are involved in astronomical research, and those are some that I work with in my own research work on variable stars. But certainly one of their most important contributions is their contribution to public outreach and education. And that's especially true of the Toronto and Mississauga branches. So this is one way that anybody out there could be an astronomer. Come to meetings of the Royal Astronomical Society, join up, and you can be an astronomer. So another aspect of astronomy, of course, is its presence in the universities. I mentioned that Canada had universities for 200 years before U of T finally opened. Our charter is dated 1827, but the powers that be couldn't decide whether it should be an Anglican university or a secular one. So the Anglicans went off and established their own Trinity College a few kilometers away. And it wasn't really until the mid-1850s that university started in its own buildings. Shown here, this is the iconic University College building, one of Canada's most important architectural buildings here. And it suffered a fire in 1890, was rebuilt, and now is being totally revitalized. And we're looking forward to the reopening of this wonderful building here. But as I mentioned, the Anglicans had formed Trinity College, the Methodists had established Victoria College, initially in Coburg. St. Michael's College, the Catholic college, was already on what's now the university campus. But they all decided that they wanted to affiliate with the University of Toronto around 1900. So Victoria College came in 1892, occupied this wonderful building here called Old Vic. But it started out in Coburg, and its founding president was Egerton Ryerson, a name that's well known in Toronto and outside, because we have a university that's named after him, unless someone decides they need to change the name of the university. But in any case, he made very important contributions to developing the public education system, which in Ontario and indeed across Canada is very proud of. Starting in 1844, even before the University of Toronto was actually opened. And one quotation from his inaugural address was that, "Surely the knowledge of the laws of the universe and the works of God is of more practical advantage socially and morally than the knowledge of Greek and Latin." Now, strangely enough, when I was in high school, there was no astronomy on the curriculum. Latin was available to me. I didn't take Greek. And a whole separate topic would be the growth of astronomy in the school system in Ontario, something that I've been very much involved in myself over the last 50 years. One of the connections between Victoria College and astronomy is that they are the host for the university's Institute for the History and Philosophy of Science and Technology. So these are the real professionals in the history of science, and they're located on the third floor of Old Vic. And one of the nice things about International Year of Astronomy is that we managed to form some partnerships between astronomy and other parts of the university, and that included the Institute for the History and Philosophy of Science and Technology. One of the things we discovered was that the graduate students in that institute were developing a virtual collection of scientific instruments. So it was an online collection, but they were cataloging and conserving instruments from all the different sciences going back 150 years. And this is something that we realized that we as astronomers needed to do. We had all these old instruments sitting around in the basement. There were instruments from the Dunlap Observatory, which we'll talk about a little bit later on. So they prompted us to start to catalog and conserve our scientific instruments as well. And our librarian, Lee Robbins, has been very much involved in this project here, along with Randall Rosenfeld, who's the archivist for the Royal Astronomical Society of Canada. Well, this brings us to Clarence Augustus Chant, who's probably the most important figure in astronomy in Toronto. And we consider him the co-father of astronomy in Canada, the other co-father being John Plaskett, who was responsible for establishing astronomy within the federal government, particularly through the building of the Dominion Astrophysical Observatory in Victoria in British Columbia. Now, most photographs of Chant show him in his old age, as this one does here, and very often he looks rather cadaverous. But I do have a picture here of him as an undergraduate. He's in the back row on the right-hand side there. So this was in his second last undergraduate year. He graduated from University College in 1890. And within 2 years, he was back at the university as a professor in the Department of Physics. So what I find quite remarkable is that he was able to establish a separate astronomy budget. He created up-to-date courses and labs in astronomy. He created a separate department of astronomy. And as we'll see in a few minutes, he campaigned for a major telescope for the university and for the city. This is quite remarkable considering that he was the lone astronomer. He was just a young fellow. He didn't have a research program, didn't have a PhD until 1900, but he managed to do all of these things here. And I'm very proud that I've benefited from all the things that he created over 100 years ago. So one of the things that happened was a number of things that were happening around 1900. One was that all these theology colleges that I've already mentioned wanted to affiliate with the university. There were also professional schools, education, engineering, medicine, also wanting to affiliate with the university. So suddenly the university was confronted with having to deal with many, many more students and many, many more disciplines. So that meant that new buildings, new faculty were needed. One of those new faculty, of course, was Clarence Augustus Chant. And one of the buildings that went up was this one here. This was the physics building, though this is where the astronomers hung out when they weren't at the Dunlap Observatory in Richmond Hill. And immediately to the right of this is Convocation Hall, which we'll see towards the end of this presentation here. The problem was that these buildings were going up exactly where the observatory was located. So one thought, of course, was simply tear the observatory down, as we unfortunately do on too many heritage buildings. But Lewis B. Stewart came up with the bright idea of simply taking the building apart and moving it to a safer location. So it was moved a couple of 100 meters to the top of a little hill here, where it still exists. It's the home of the University of Toronto Student Union. And one of the most significant buildings of a scientific nature that still exists in Canada. And a good lesson for all of us when you have the choice between tearing down a historical heritage building and doing something creative with it, then of course, if you could do something creative with it, that's all the better. So the meteorological function moved from the campus to this well-known building here on Bloor Street on the north side of the university campus. It's now the Monk School of Global Affairs. And if you look at the top picture here on the left-hand side of the roof, there's still the foundation there of the astronomical dome of the building there. And just to the west of this building, shown in the bottom picture, there's this little window here, which is very narrow, and that's a narrow window through which the telescope could point to measure the time at which stars cross the north-south line for purposes of keeping time by the stars. Something that not many people have ever seen, but it's certainly one of the things that we look at during our heritage tour. In fact, the next stop on the tour is the Royal Ontario Museum, also dating back just over 100 years here. It hosted the McLaughlin Planetarium, and I'll tell you that sad story in just a couple of minutes. What's not so well known is that it still has an active astronomy education program using small planetariums, and it has a wonderful collection of meteorites. And it's about to open a Dawn of Life gallery that connects with some of the ideas of the origin of life on Earth and perhaps elsewhere. So one of the things that the museum became involved in was in 1950, a prospector alerted them to the existence of this strange looking feature in northern Quebec. It's about 2 miles across, and it looks very much like a bullet hole in the crust of the Earth. Well, we now know that it's a meteorite impact crater. So the ROM sent out an expedition to explore it. And then the next year, the National Geographic Society sponsored another expedition. Of course, that gets you an article in National Geographic magazine, lots of publicity, and Canada's gone on from there to become a major center for studies of meteorite impact craters, which we indeed have many of across our country. I mentioned the meteorite collection at the ROM, and what they have a particularly good collection of are things called carbonaceous chondrites. And these are rare meteorites that have been unchanged since the birth of the solar system 4.5 billion years ago. And they're carbonaceous because they contain a few percent carbon in the form of complex organic molecules, indeed the building blocks of life. And these have formed naturally in the material from which the meteorites formed 4.5 billion years ago, from the material that our solar system in general formed from. So what these tell you is that the elements of life can form naturally and easily, even in the hostile environments in space. So another outcome of Chant's work was the David Dunlap Observatory. I mentioned that he was very much involved in public outreach. He was a writer, he was a frequent speaker, and at the end of one of his public lectures, a mining lawyer by the name of David Dunlap came up and expressed an interest in Chant's dream of having a major observatory for the city and the university. Sadly, Dunlap died a few years later before anything had transpired, but after David's death, Chant approached his widow, Jessie, and she agreed to donate the funding for an observatory, which would be part of the University of Toronto, located in Richmond Hill, just north of the city. And when it opened in 1935, it housed the second largest telescope in the world. So it was definitely a center of the universe for astronomical work, very much involved in research. I was part of that back in my student days. Its most famous discovery I'll tell you about in a minute. But as time went by, the use of the observatory for research declined. The weather wasn't really suitable. There were better sites elsewhere. And finally, it was decided to sell the surrounding lands to a developer, and the proceeds were used to endow the Dunlap Institute, which I'll mention in a few minutes. But it is still active in public education. It's owned by the Richmond Hill, operated by a number of organizations, including the Royal Astronomical Society of Canada. In fact, they have a virtual program going on this summer. I think next Saturday is their next presentation, but if you just Google a Dunlap Observatory, then you can find out about the public education that they're involved in. But certainly their most spectacular research discovery in 1972 was the discovery by Tom Bolton, my colleague, of the first black hole in space. And in the middle picture on the top there is a star that was apparently emitting X radiation, which is very abnormal for a star. So Tom studied the star using the Dunlap telescope shown on the right there, and discovered that that star was in orbit around an object that turned out to be a black hole, an object which was actually the end product of a very massive star, but something so massive with such a strong gravity that nothing could escape from it, not even light. So that was very famous. It was actually a co-discovery by astronomers in the UK, but Tom and his students continued to study that and established then the existence of black holes in space. The best known and certainly most beloved astronomer at the observatory was Helen Sawyer Hogg. She was not only an eminent researcher on star clusters, a teacher at the university, a leader of astronomical organizations, pioneer woman's physical scientist in various organizations, a companion of the Order of Canada, etc., all done while she was a single mother, and very well known because she wrote a weekly astronomy column in the Toronto Star, Canada's largest circulation newspaper, for over 30 years, was an author, a lecturer, a TV host. I remember being on a program with her and with Carl Sagan, one of the highlights of my astronomical life. Well, we come to another turning point in the history of astronomy at the University of Toronto and at Toronto in general, and that was the things that were happening after the Second World War. One thing was that thousands of servicemen and women were being offered free education. Lots of them chose engineering, and they actually had to build a complete new campus of the university for a few years just to train all these engineers. There were developments of technology such as aerospace, electronics, computing, and so on and so forth, and further expansion of science and engineering after Sputnik, part of my own university career, and of course the Cold War, when science and engineering had a much higher public profile. And last but not least is the baby boom that occurred after World War II that echoed through the school system and then into the university system in the 1960s. and in a sense was responsible for me having a job when I graduated from the University of Toronto. So in the area of radio engineering, for instance, a collaboration with astronomy had led to the development of radio astronomy, the realization that cosmic objects emitted radio waves. And at the University of Toronto, that involved a distinguished engineer, Alan Yen. He was university professor with a capital U. That is the highest rank of university professors at the University of Toronto. And among other things, he and other astronomers and engineers developed a technique called long baseline interferometry. And that's the technique that was used to obtain this incredible image of a year ago of a black hole at the nucleus of a galaxy. These things occur at the nuclei of many galaxies, including our own. And this image was obtained by having many radio telescopes imaging it at the same time and combining their results into a single very high-tech image. Now, I particularly like this picture here. On the left-hand side, this is University of Toronto's first computer, Ferret. It was made by Ferranti, a British company. And what's interesting in it is that it doesn't look much different than when I started using computers back in 1960. You had these huge rooms full of hardware that would probably fit comfortably in your smartphone now. Also a shout out at the bottom for Beatrice Worsley, a pioneer woman computer scientist. Unfortunately not well treated at the University of Toronto, so she ended up, I believe, at Queen's University, but played a very important role in computing in Toronto in the first years. So again, this is a technology that came out of World War II and computers being used for various purposes, including code breaking. Now, this is my first boss. This is J. Tuzo Wilson, who founded the geophysics program at the University of Toronto and very much in Canada as a whole. And so this now expands to include not just earth science, but planetary science. But he became principal of the U of T Mississauga, which, as Mike said in the introduction, I was a founding faculty member there in 1967, which is why he was my first boss. And when he had to retire from the university, he became director of the Science Center. When he had to retire from that, he became chancellor of York University. And after that, he just went back to his research work. So this brings us to the McLaughlin Planetarium. This was something that was proposed by the University of Toronto, which actually was responsible for the Royal Ontario Museum in 1968. And also by the Royal Astronomical Society of Canada. And for a few decades, this was one of the world's major planetariums. So again, a center of the universe kind of thing. Now, the problem was that in 1995, the museum decided to close the planetarium. Very unfortunate and unnecessary move. It was partly because of change in government and something called the Common Sense Revolution and some uncertainty of the funding of organizations like the ROM. But that was the time when I happened to have been on the board of the Science Center. So we simply soldiered ahead and managed to deal with the Common Sense Revolution. But one unfortunate aspect was that shortly after the planetarium closed, astronomy finally became a compulsory part of the elementary and secondary school science curriculum. And so this facility, which was so important in education, was no longer available. Another offshoot of the baby boom was York University, Toronto's second largest university. It was initially part of U of T, then it opened a small campus in '61, and then its major campus, which is absolutely huge now. It has an active astronomy and space program, but it's particularly well known for its public outreach program, its small observatories. It actually has an endowed chair in science and astronomy communication. So it does tremendously good work in these fields here. But then the University of Toronto felt that it needed to expand. It didn't have room on its old campus at the center of the city. So it created two new campuses, one to the east in Scarborough and this one to the west in Mississauga. This is where I spent the first 40 years of my academic life. It was very much involved in many aspects of astronomy, directly or indirectly. It was where the studies of magnetic properties of the moon rocks from the Apollo missions was done. It was actually where Tom Bolton was stationed the year he discovered the first black hole in space. And Roberta Bondar, Canada's first woman in space, did her PhD here in neurobiology. So a very distinguished tradition in astronomy. Well, that brings us to the Ontario Science Centre, which I've mentioned before. It was a slightly late centennial project, but it has certainly become one of the world's foremost science centers, very much in the hands-on, minds-on, community-based tradition. Another example of us being the center of the universe, and astronomically too, because it now hosts the Toronto Center of the Royal Astronomical Society and other astronomical exhibits, programs, workshops for teachers, and so on and so forth. So back to the research side of astronomy, I mentioned that sky conditions at the Dunlap Observatory had deteriorated, and astronomers became aware that there were sites in Chile and Hawaii that were much, much better. So there was a huge rush to start building observatories in these absolutely superb sites elsewhere. And the U of T got onto the bandwagon by building a small observatory shown in this picture here, the University of Toronto Southern Observatory, which at least by one measure was the most productive observatory per dollar spent anywhere in the world. So, center of the universe. Unfortunately, with cutbacks in funding, this observatory has had to be closed or at least moved to another location. But Canadian astronomers have lots of access to other facilities now all over the world and also in space. But the University of Toronto Southern Observatory certainly got its publicity in 1987 when Ian Shelton, who was a staff member working there, discovered the brightest supernova in 400 years. So on the right-hand side, you see the supernova or the star that went supernova, and in the middle, the supernova at its brightest when it was easily visible to the unaided eye. So that was exciting because now astronomers had all kinds of space facilities, ground-based facilities that could be used to study this remarkable process here. Now here's something that's center of the universe class, but is not very well known by Canadians, and that's the Canadian Institute for Theoretical Astrophysics, hosted since 1984 by the University of Toronto, and a very cost-effective way to do world-class research, because basically what you need is some really bright people and some good computers, and away they go. And Dick Bond was for many years the director of the Institute. I think he's serving temporarily right now as well. And he is certainly one of Canada's most outstanding astronomers, many, many different awards. We're very proud of him. Here's another area that sprung from World War II, and that is interest in aerospace studies. So the University of Toronto developed an Institute for Aerospace Studies quite early on. It's located north of the city. And one of the things that it did was to build this rather unusual looking astronomical satellite here. Its technical name is MOST, Microvariability and Oscillations of Stars, but it's usually called the Hubble Space Telescope because nobody's ever heard of it. It's about the same size as a suitcase, worked way past its shelf life, and UTIUS went on to build several more nanosatellites. These are about the size of car batteries, and one of them didn't function, but the other 5 of them are busily orbiting the Earth right now, doing excellent work in the same kind of research that MOST was involved in. Now, if you can't afford a satellite, the other way that you can put your instruments in space is to use a high altitude balloon. And if you fly it from Antarctica during the Antarctic summer, then it will observe the sky for days and days on end, because there's no daylight night cycle to interfere with the balloon. So many useful studies have been done, particularly studies of the leftover radiation from the birth of the universe. And it gives our graduate students a wonderful opportunity to go down to Antarctica for a once in a lifetime opportunity to do science, such as you see on the left here. Well, that brings us to the Dunlap Institute. As I mentioned, this started in 2008. It was funded by the proceeds of the land around the Dunlap Observatory. This was a project of the Dunlap family working with the University of Toronto. And it has four major aims: innovative instrumentation, creative observations, training young astronomers, and strong public outreach like Cosmos from Your Couch. And this is important because it allows us to carry the Dunlap name into the 21st century. So the Dunlap Observatory may not be doing quite as much as it was when it was founded, though, as I said, it's still very much involved in public education. But the Dunlap Institute is now front and center and well known around the world for all of the things that it does. And one of the things that it's particularly keen on is diversity. Lest you get the impression that all astronomers are graying white males like me, here are my young colleagues in the Dunlap Institute. There are other young astronomers who are in the department who are technically part of the Institute, but certainly diversity and equity are things that are very important to us. And besides, it's fun to work with such a creative and bright group of people. That's why I'm still an active professor emeritus and not walking out into the sunset. So a word or two about teaching astronomy, because that's a huge amount of the work that we do. I mentioned Convocation Hall, which is the gathering place at convocation and things like that. But it's also where we give our mega courses of 1,500 students. These are primarily for non-science students who want to take courses in introductory astronomy. Unless you think it's impossible to teach courses of 1,500 students, it can be done by our best instructors. And there's no one better than Mike Reed, the host of this presentation this evening, an award-winning instructor. And if you use best practices, technology, pedagogy, charisma, concern for students, supplemented by small group tutorials and even a small planetarium, it is possible to do a really good job like this. Now, of course, we can't have gatherings like this right now and in the fall, so I'm watching with amazement at Mike and his colleagues who are developing our teaching of astronomy for this fall, when we are constrained by all of the constraints that the pandemic has imposed upon us. So in addition to these courses, we have programs for science students. We have a graduate program that attracts graduate students from all over the world. Again, a center of the universe kind of achievement. And then there's our public outreach. Outreach is done not just by professional astronomers, but as I mentioned earlier, by our amateur astronomer colleagues in the Royal Astronomical Society. They do it voluntarily. We do it also because we love doing it, but also because it's part of our accountability. The taxpayers out there pay our salaries and pay for our research, and the least that we can do is to share our passion and our knowledge and what it is that we do with a public audience. So the bottom picture here is the RESC getting set up for a star party. The top picture is some of the thousands of people who gathered a few years ago to watch the transit of Venus from our varsity stadium. Now, this is an interesting picture. This was a gathering of thousands of people who came out on a mostly cloudy evening to watch an eclipse of the supermoon. And we've been doing events of this size for the last few years. And one of our little challenges, as Mike knows, is how do you take an event like this and put it online? So what we are doing right now is to try and figure out how do you take an event for 5,000 people, which we normally do in September. It's our planet gazing party. And how do you do it online? So check back in with us in a few weeks and you'll find out how we do it, or Mike might even be able to tell you a little bit about it during our question period, because we're working very hard on this right now. One of my interests is the way that astronomy connects with arts and culture. And my favorite International Year of Astronomy project was actually with Toronto's Tafelmusik Baroque Orchestra, which is regarded as one of the best in the world, certainly center of the universe caliber. And they created a program called the Galileo Project, which toured around the world to great acclaim, fusing together music and theater and images and astronomy together. And you'll notice the orchestra doesn't have music stands there. They memorize the entire score. They're free to move around and do their choreography and so forth. So one of the great things about astronomy is the way that it connects with so many other things in our life. Well, I always end my talks with this cartoon here. Mr. Osborne, may I be excused? My brain is full. I've tried to tell you a little bit about how astronomy has developed in Toronto over the last 150 years or so. There's lots of things I haven't told you. I probably haven't given you enough credit to York University, our partner in the north part of the city there. But in any case, I hope that you have lots of questions and we can fill in some of the gaps. So thanks very much for listening. I'll finish off with this lovely picture of University College against a beautiful dark sky there, obviously photoshopped. And it was by Henry Leung, undergraduate student who worked with me, now part of our graduate program. So I'm going to turn it over to Mike, and Mike has collected all the questions together.
Okay, wonderful. Thank you very much, John, for that really, really interesting talk. It's always very interesting to learn about, all of the bits and pieces of the story of astronomy in Toronto that you somehow miss, even though, people like me, I grew up in Toronto and have lived here.
Now, while I have you there, do we have a definite date for the planet gazing party online?
We don't have a definite date yet, so thank you for mentioning that. But we're not quite ready to announce a definite date, but it'll very likely be mid-September. Yeah, I think it's very likely to be the second weekend in September.
Okay, stay tuned.
Stay tuned, indeed. We'll definitely be announcing that on the Dunlap Institute social media shortly. So in terms of questions, I have a question for you, actually. So the old observatory on the U of T campus that, as you mentioned, is now a student union building. I wonder if you know anything about, efforts to preserve it in the long term, or to preserve its nature as an observatory in some way.
Well, as an observatory, I don't think it will be preserved, but I see no reason that it should ever be torn down, at least in the foreseeable future, partly because it's such an iconic building. Secondly, it's in a place where I can't imagine the university wanting to put a major building, but I think there would be a huge hue and cry from all different sectors if there were any move to tear down that important building. Certainly there'd be a hue and cry from me and from Heritage Toronto, I'm sure. And I thank Heritage Toronto for all the support they've given in developing this walking tour and this talk here.
Okay, thank you. So we have another question from the chat here, which is, does the McLaughlin have a future? Will it ever be reopened?
Oh, that's actually a good question, because that's something I should have actually mentioned, as you realize. And the answer is that the McLaughlin is really just a shell now. It's just a storage area. It's now being transferred back to the University of Toronto. There will be another building erected on that site there. There was consideration to putting an astronomy building there, but it turned out to be an inconvenient location because of all the vibration that would be very difficult for our lab facilities. On the other hand, as Mike knows very well, there are plans for a reasonably major planetarium as part of a new building that is going ahead for the astronomy group at the University of Toronto. An architect is already working on this. Mike, do you want to say a word or two more about that and the planetarium?
Sure. So yeah, somebody's asking, the McLaughlin is just a shell. Yeah, it is. It's presently, there are a lot of people who want to, or maybe imagining that we could kind of just go in and turn on the lights and start it back up again. But it is unfortunately, largely gutted. I haven't been in there for many years, but it's no longer a functional planetarium. It hasn't been for some time. But I was part of one of the groups that was working on trying to put a new planetarium on that site as part of a new astronomy building. And as Dr. Percy mentioned, that didn't go through because there are a number of problems with that site. In part, it's sitting on top of the subway, which is a great thing for a planetarium, but a terrible thing for astronomical research. And so we couldn't locate a new planetarium there. Because it had to be done as part of a new astronomy building. That said, we will be building a new astronomy building at some point over on St. George Street, we believe, and there is an architect engaged. They are doing the designs. There are meetings. Exactly when that will happen, we don't know. The world is quite uncertain. Yeah, especially these days, we don't know a lot of things. So we know what the plans are. We know what the prospects are. But, we kind of have to wait and see how the economy goes and whether or not the funding is in place to build what we want to build. But what I can tell people is that there is definitely a substantive planetarium included in the plans for a new.
Yeah, and another thing that a lot of people don't realize is that the university's been operating a small planetarium, really under the leadership of Mike, both its outreach work and its use as part of our mega courses. And we are hoping to find some way of having that small planetarium continue to operate for the next year or two or three until we can get the bigger one going. And that's something, again, that Mike has been very much involved in. There's also a small planetarium at the Science Center. And one thing to realize about planetariums is that the most important part of it is the projector. And nowadays, you can get very powerful projectors even for a relatively small planetarium. So I do recommend the one at the Science Center, and certainly ours once it gets up and running again.
Yeah, and we may actually be in a even better position with regard to planetariums in Toronto in 10 or 20 years. The Science Center, I think, is considering renovating their planetarium. And there are a couple of other groups that are proposing to build planetariums of various sorts.
Yeah, that's been going on ever since the McLaughlin closed.
Yeah.
And certainly when I was vice chair of the board of the Science Center, I was constantly developing or encouraging proposals to build a planetarium there, because that would be a very sensible site for a planetarium. But one on the university campus would be even better, because then people like Mike could use it for teaching as well as a public facility. Okay, we better get back to the questions now.
Yeah, so there's another question here, which is, does Dr. Percy, are you still doing historical walks?
I was scheduled to do 2 this summer, and I'm not aware that we're going to be able to give either of those. Simply because of the regulations around the pandemic. I suppose it's conceivable that the program will pick up in the early fall if we get into phase 3 or something like that. But the answer is, I guess, wait till next summer, I hope.
So if people wanted to, be aware when you offered a walking tour, where would they go for that information?
You go to Heritage Toronto, and if you go to their website, they have various interesting things that are virtual in nature. Now, I've put up here some web links to the Heritage Walk, so you could actually, if you can copy down these things, or they'll be archived along with the presentation, is the slides themselves, and also the script and a map for the walk, and a couple of books here on the history of Canadian astronomy from the point of view of more professional historians than I.
Okay, wonderful.
So yeah,
Thank
I
you.
hope to offer the walk in the future.
So pay attention to the Heritage Toronto website.
Yes.
Another really interesting question. I'm very glad somebody asked this. Can you tell us anything about the Algonquin radio telescope? Is it still in use?
Yes, it is. I don't know as much about it as someone like Mubdi Rahman, who does our 1,000 Words series. He and the group at the Dunlap Institute are actually building a small radio telescope that's going to be part of a network. But as far as I know, the main antenna is still used for certain kinds of geodetic and astronomical work. There's some very creative work going on in the Dunlap Institute in the area of something called scintillometry, which is a way of using radio telescopes and the interstellar material to actually produce sharp images of strange objects like neutron stars and so forth. And the facility is still there. I can't remember the exact ownership of it and how one gets to use it, but it is there, and it had a very noble time back in the 60s and 70s and 80s. It was involved in this technique called very long baseline interferometry, being connected up to a radio telescope in Penticton, which together were able to obtain incredibly precise, sharp images of strange radio sources called quasars, which are caused by supermassive black holes in the nuclei of galaxies. So sorry, I've talked around the answer.
No, that's wonderful. So yeah, I'm also not entirely sure. It's definitely still, the Algonquin radio telescope is definitely still in use for research. I think it might also be open to the public now as a sort of bed and breakfast. It was, I'm not sure if it still is, but if you're interested, you could Google around and check.
Yeah, that's right. Always go to Google.
Always Google. So let me just check for more questions here. So somebody was asking, where is the small planetarium? So I think if you're referring to the one that Dr. Percy mentioned at U of T, it's currently nowhere. It's currently in a box, but it will be unboxed and restored to a new location, hopefully soon. We don't know when because of the pandemic, but when it is, you'll know more if you pay attention to Dunlap social media. Okay, I'm just looking for questions. I don't think there are any other questions beyond that. Yeah, I think that's it for questions on the chat. So Dr. Percy, I would like to thank you again very, very much for tonight's really, really interesting talk. We're very pleased to hear more about the astronomical history of Toronto, and I hope that people who joined us this evening will consider joining you in person for one of your live talks, live walks, when that becomes possible again. So thank you very, very much.
Yeah, my great pleasure.
Okay, take care, everybody. Good night.